Good day and welcome to this video in this series teaching C#.NET for engineers. In this video we are going to take a look at C# classes, and we are just going to look at an overview of the basic concepts, and in the next video we are then going to go into Visual Studio and look at a hands-on example of a class file. Now, in a previous video, I think that was specifically our third video, we looked at the code structure in a C# solution. We showed that the solution is the overarching container for the code in a Visual Studio project, and within a solution you can have one or more projects. And so here in the example that we did in earlier videos, we created one project called My App, which was a console application, and we created another project called My Library, which was a class library. We then explained that My Library can be referred to from My App, so that My App can make use of the code in My Library. And we showed you how this can be done in Visual Studio, how you can create a reference from one project to another. We then explained the concept of namespaces. We have in our example a main namespace with classes inside that, and another namespace called utilities with classes inside that. And we noted that a class maps to a file in C#, and it's good practice to have the name of the class match the name of the CS file that you create in Visual Studio. We also said that you can have the same class name in a project provided they are not in the same namespace, because a namespace basically in Visual Studio maps to a folder. You can't have two files with the same name inside of a folder. We did the same for the library project, and we also noted that although we are using names like class 1, class 2 here to explain the concepts, in practice you would never give a class a name like that. You would always give it a much more descriptive name, such as calculator class or file operational class, etc. Okay, so now that we understand that the class is one of the most important units inside a C# project, let's go and take a closer look at the class file itself. So here we have the file. So this maps to a physical file on your hard drive, statistics.cs as an example. So let's say this is a class in which we want to calculate some basic descriptive statistics. And so inside of this file, at the top, we are going to have some using statements which basically specify which other libraries or projects we want to make use of inside of this file. And that is basically just to prevent us from having to type out the whole path to the specific class that we want to be looking at. For example, if we want to access a class in another library in a specific namespace, so we can refer at the top say I am using my library dot namespace file operations, and then I can have access to all of the classes inside of that namespace. So this is quite important, and you'll see in Visual Studio when you create a new class, it automatically puts some using statements at the top to refer to standard libraries and namespaces inside the .NET that you are likely to make use of in your class. So then we have a modifier. I'll explain what a modifier is in a moment, but that is just a word. Typically it would be public and then the name of the class. And I also said earlier that the name of the class ideally should match the name of the .cs file. So if this was a real class where the file name was statistics.cs, the class name would be simply statistics. And then we have our curly brackets, open and close, and everything that fits inside the class needs to go inside of these braces. I can't write underneath it, and except for the using statements, and of course also the namespace, which I've omitted to show here, but it will come above the class name. All your code fits inside of these braces. So basically that is where your C# code for the class is going to be. At the top, normally you will have a set of statements which are variable declarations. We gave an example and discussed that in the previous video. So all of those, typically I like to put right at the top of the class. And then you have a block of code which deals with properties. Now you can put properties anywhere, you can distribute them throughout the class. I like to put them inside of something called a region. We'll look at the regions later, and so that you can collapse all of the properties and all of the variables and put them in separate regions in a C# class. Below that then you're going to have the methods. So if you're coming from, for example, a R or a Fortran background, these would be mapping to functions, a method, and you have method 1, method 2, etc. And of course, once again, these would have much more descriptive names if you are going to do this in actual productive code. Alright, so that's the basic structure that you would see in a class. And just note that these methods, they can call each other. This method can refer to make a call or make use of method 3. They could make use of a property and could make use of a variable and so on. And so this is where the modifiers come in, because they allow us to restrict how visible or accessible a variable or a class is inside your C# solution. So if we look at modifiers, modifiers is basically a word that you put in front of a class name or of a method name or in front of a variable name, and that determines their scope. Scope refers to how widely a variable is visible or accessible inside and outside a class. So common modifiers that you will mostly run into, there are more, but 80% of the time you will only be using these three. Is public. This means that the class, the method, or the variable is accessible everywhere in the whole solution, right? Private means that the method or the variable is accessible only inside of a class. There's not much point, I'm not sure even if you can do that to make a class private, but normally you would use private modifier to describe the scope of a variable or of a method inside of the class. And then internal, which means that the class, the method, or the variable is accessible everywhere, but only inside of the project. In .NET, it's called an assembly in which it is declared. All right, let's look at some examples. Before we do that, I just want to point out it's good practice always to choose your modifier such that you only expose classes or variables where it is needed. If you think that a class is only needed inside of a library and you don't want other projects to call that class, then make it internal rather than public. And similarly, if you have a variable inside a class and you want that variable only to be visible inside a class, never make it public, always make it private. Okay, so as I said here, be especially careful to mark variables inside a class as public. If you do that, it means they can be modified from anywhere, and you modify it, in other words, you can change their values from anywhere inside your solution, and that may not be something that you want to do, because maybe later on someone else is going to have access to your code, and maybe you ask them to help you to maintain the code. They don't quite understand how it works, and they go and mistakenly modify a variable in a class, and it has disastrous consequences throughout your solution. So be quite careful to choose modifiers such that you only expose those classes or variables where it is needed. Let's look at an example of public access. If we mark class 4 here in my library as public, it means that that class 4 can be accessed anywhere inside of my library and anywhere inside of my app. So it's basically visible inside of this entire solution, right? So that public is the widest possible scope that you can assign. So it's an important modifier for classes, but be careful of using that for variables. Internal, if we mark, for example, class 5 as internal, then that means that class can be used inside of this library. You can call it from class 1 or class 2, anywhere here, but you won't be able to access it from my app because it is internal to this library. Okay, so that's it for these concepts. In the next video, we're going to design a class to do something useful in an engineering sense, and I will do a hands-on example to show how we structure and use that code class. So that's it for this video. Thanks for watching.